Today's lesson is going to talk a little bit about using factoring to expose x-intercepts of graphs. And before we begin to do that, I just want to review some things that we know about quadratics. So things that we want to be able to tell about little a right here is that it should be smiling, and that we want to remember there is a plus 0 at the end of this, which means the y-intercept is 0. So we're looking for a smiley face whose y-intercept is 0. So it looks like it would have to be graph E. Almost the same thing with the next function, only it's a frowning face, but the y-intercept is still 0. So if you look for a frowny face whose y-intercept is 0, you'll find that that is letter A. Then we have a smiley face whose y-intercept is 1. So it looks like that will be letter D. We have a frowny face whose y-intercept is -1. Which looks like letter F. And then a smiley face whose y-intercept is 2. That would have to be C. And then the last one would have to be B. So the y-intercept was a great way to tell these graphs apart, as well as knowing if they're smiling or frowning. But if you had two y-intercepts that were the same, you wouldn't be able to differentiate based on that information. So what we like to focus on is, you know how to find y-intercept. It's very easy to do. We know how to find h and k, which is a little less convenient, and we really didn't have to do that for these. But we're also going to figure out how to find the x-intercept. So if the y-intercept wasn't helpful in figuring out these graphs, then perhaps the x-intercepts are, and that's what we're focusing on in this unit. All right, so we have a couple of vocab words for you guys today. Nothing really complicated. So sometimes in a problem they'll ask you to find the roots of an equation or the roots of a function, and really all they're asking for is the x-intercept. So you just have to know that root means x-intercept. And then sometimes they say find the zeros of the function, which technically does mean find the x-intercepts, but sometimes we like to refer to 0 as all solutions such that y equals 0. So if they ask for the zeros, they want you to plug 0 in for y and find all the solutions for x. So really the process is the same on your guys' end. You put 0 in y spot and then you solve for x. So the method of which you solve is not changing. I think that the reason they try to differentiate root from 0 is that if you were to get an imaginary number answer, such as the square root of -2, right? We cannot graph the square root of -2 on the Cartesian coordinate plane. So you would say, oh, it doesn't have an x-intercept. But if they said find the zeros of the function, they could possibly want the imaginary ones as well. So imaginary numbers is actually something we do in the next topic. But for right now, just know that if you're finding root or 0, you just plug 0 in for y and solve it. They're not going to ask you which one's a root, which one's a 0, because they're pretty much the same thing. And then there's 3 methods that they want you to know for solving quadratic equations. The first one is through graphing. I am never going to ask you to solve by graphing because it would be kind of pointless. The only way that you would graph perfectly is if you factored and found your x-intercepts. So it seems silly that they would say, oh, solve it by graphing, because you would need factoring to graph it. But I will ask you to graph parabolas and show me the x-intercept. So just know that if they ask you what's the or what are the zeros or what are solutions, they're asking for the x-intercepts. We will use something called the square root method. And basically the process is you'll get something that's squared. You want to get that squared term by itself, and then you're going to take the square root of both sides, and then you're going to simplify if possible. So I walk you through that whole process, so you don't have to worry about what all that means right now. But what I do want you to consider is if, let's say, you got x equals root 12, for instance. If you leave that as an answer, I would take off half a point. I would expect you to change that to 2 root 3. So that is deemed as an Algebra 1 skill. Some teachers don't quite get to cover square roots enough, or it's very, very fast, because it happens typically in the end of the school year, depending on who your teacher is. So we will review that in the next lesson. So we do square roots, and then after that we do imaginary numbers. So we will take you through that again, but just so you know, that is what I mean by simplify. And then last but not least, we can solve by factoring. Sometimes. Sometimes it factors out nice and pretty, and sometimes it doesn't, and you'll have to use a different method. but if it does, it's very efficient and very, very convenient. So what you would do is you would factor the polynomial, right, using your little x method. You set each factor equal to 0, and then you would solve for x. So we're actually going to do 3 examples where we solve by factoring so you can see what that looks like. So I'd like to do 7, 8, and 9 as a class. So never mind, I know the numbers start off with 7, 8, and 9, but that's okay. We'll just pretend that says 1, 2, and 3. All right, so we want to solve by factoring. So we are going to factor it, but don't forget, the task is to solve the equation. So you're finding all values for x that make this equation true. So rule number 1 is we want this side to be 0. All right, so you cannot solve a quadratic equation unless you have 0 on one of the sides. That's because we use what's called a zero product property in our final step of work, and unless you have the function equal to 0, you cannot use that property, so you're going to find yourself stuck. All right, so if we're going to use factoring, we have to make sure this side is 0. So because a is 1 in this trinomial, I can go ahead and use the 36 and the negative 12 in the problem, and my magic numbers will be negative 6, negative 6. So I would go ahead and set up my parentheses with x minus 6, x minus 6, bring down the equals 0 because you don't want to forget that your task is not to factor, it's to solve. You're just getting there by factoring. What we do then is any parentheses that we have to treat as if it could equal 0. So we want to make this parenthesis equal to 0 and this parenthesis equal to 0. So if you had 4 other sets of parentheses, you would have to take all of those and make it equal 0 as well. All right. Now these are obviously, this is going to get you the same answer, but this is ideally the motion that you would follow. All right, so I'll just solve one of them and get 6. So the x-intercept is 6 of this graph. So what does that mean for us? That means if you were to graph this as it is right now, you would know the y-intercept is somewhere way up here at 36. The x-intercept is only 6, so my graph would look like this. So this parabola has one x-intercept and only one x-intercept. All right, number 8, we are not ready to go with our factoring because we do not have our quadratic equal to 0. So I like to keep my x squared positive. I will subtract over the 14x and add over the 40, and that should equal 0. So now I'm ready to go ahead and begin my factoring. And again, a is 1, so that makes this very nice. I can use 40 and negative 14 and find my 2 mystery numbers, which would be negative 10 and negative 4. So I'm going to set up my parentheses. And again, I take each parenthesis and treat it as if it could equal 0. So this parabola will actually have 2 x-intercepts, one at 10 and one at 4. And again, if we were to graph this scenario, the graph would look like a smiley face, since my x squared is positive. And I would have a 4 and a 10. The y-intercept is way up here at 40. And if I have to go through 10 and 4, that would mean your vertex would have to be down here somewhere. So that's a rough sketch of the graph, but you can see both x-intercepts are exposed. All right, and then number 9, again, we can see that this is not ready to go. I want one side to be 0, and I like my x squared is positive, so I will be adding over to make 6x squared, which means I must subtract the 4x to make 1x minus 1 equals 0. Now we have to be careful here because a is not 1, it is 6. So you cannot just put negative 1 on the top and 1 on the bottom. Okay, that only worked for problems like 7 and 8 because that leading coefficient was 1. So we have to do our 6 times -1 and get -6. The middle coefficient is 1. And I have to find two numbers whose product is -6, whose sum is 1, and that's going to get me -2 and +3. So then what I'm going to do is I'm going to take this 6x squared, I'm going to copy it down, but I'll no longer write 1x. Instead, I'm going to break it into -2x and +3x. I still have the -1 right here, so that comes down equals 0. So let me just recap what I did here. I have not changed the problem at all. I have just rewritten it in such a way that I'll be able to factor it, because -2 and +3 would get me right back to this 1x. The 6x squared and the -1 are still there, so I have not changed the problem, just reformatting it. From there, the whole purpose to doing this is so that I can group 2 and 2 together. And I'll continue my work down here. So then I want to factor out the GCF, which would be 2x from the first group, and that would leave me with 3x minus 1. Now, some kids look at this and they're like, well, there's no GCF. There's always a GCF, and you have to factor out a GCF. The GCF in this case would just be 1. So there will always be a GCF. If you can't find it, then it's probably just 1. And I do not want to forget that all of this should equal 0. Last but not least, I'm going to pair up my GCFs to make 2x plus 1. And then I just keep my group 3x minus 1 equals 0. So a lot of kids will do all this work, they'll circle it and say, there, I factored it, which is great that you factored it, but you have not solved the equation yet. So we have to set each parenthesis equal to 0. And we have to solve each one separately. So it looks like your values will be -1/2 and 1/3. So this parabola would have 2 x-intercepts on it. All right. That is all I'm going to do in this video. In the next video, we'll pick up with number 10.